Hey guys, here's your video notes on reference frames. And you can title it that. First thing I want you to do is draw this situation with a train moving past a platform. So I got a train with a window on it. I listed the velocity of the train up there at the top. Let's see if we can move it. There we go. Velocity of train, 30 meters per second. There's a passenger who is just standing on the train. There is a runner on the platform running to the left or in the negative direction, negative 10 meters per second. There's a suitcase sitting still on the train, and there is, as you can see with his top hat, a magician who is just standing on the platform. All right. So draw, the platform, the train, and label all your velocities. Now, there's also a ball being thrown the opposite direction that the train is moving, and I should say that that speed, 20 meters per second, is the speed that the passenger, how fast that passenger could throw a ball. So that speed is relative to the train, or somebody watching it on the train would see that ball going backwards at 20 meters per second. Whereas the runner is moving at 10 meters per second relative to the platform, his reference frame. And the train is moving 30 meters per second to the right relative to the platform as well. Alright, so take a moment to draw that. You can pause the video and then we'll solve the problem. Okay guys, so now let's resume after you drew that. There is a table down here that we're going to use to describe how three different reference frames, the magician, the passenger, the runner, those three people, how they observe the magician, the runner, the suitcase, and the ball moving, right? So basically the object you're observing goes down the columns and the reference frame goes down the rows. Alright, so draw that for yourself as well. So row 1 is going to be magician, and how does he see himself moving, the runner moving, the suitcase moving, and the ball moving? We should say left on this diagram. Anything moving to the left is negative, and anything moving to the right we're going to call positive. Alright, anything we see, if you see it moving to the left, it's a negative velocity. If you see it moving to the right, it's a positive. So things can change from negative to positive based on reference frame. Who's observing it, the magician, the passenger, or the runner. Alright, so draw that table for yourself. I'll unpause the video and do that. Okay, now I want you to do the first row. Alright, how does the magician see himself? How does the magician see the runner moving? How does the magician see the suitcase moving? And how does the magician see the ball moving? Try this, try to get all four right, and then you could watch me do it next. So pause the video, try to do it on your own right now. And then now I'm going to do it. Alright, so I'm going to solve the first row for you. Anything with magician versus magician, it's basically 0 if they're observing themselves. So we're going to write an X there. How does the magician see the runner moving? So the magician plainly sees the runner moving backwards at negative 10 meters per second. They're both on the platform. How does the magician see the suitcase moving? Well, the suitcase is on the train, just in a seat on the train. So the train's velocity is pulling the suitcase to the right at 30 meters per second. The magician is standing still on the platform, so he sees that as a positive 30 meters per second, or to the right at 30 meters per second. How does the magician see the ball moving? Well, that takes into account two things. The ball is on the train, and the train is moving to the right while the ball is moving to the left. So everything on the train moves 30 meters per second to the right, but the ball moves 20 meters per second to the left in that train reference frame. So it's kind of like 30, magician sees the ball get 30 to the right, but it sees it get 20 taken away from it. So it sees the ball at positive 10 meters per second. Alright, so those are the answers to row 1. Ask me if you have any questions with it. You could pause it and talk to me. Alright, next do row 2 on your own. And pause the video here. And then don't listen to me give you the answers yet. So, what does the passenger see? Okay, so the passenger, how does he observe the magician moving? Well, the passenger's on the train, and the train's moving to the right. So anything on the platform seems to be falling behind the passenger and moving to the left. For instance, if you're a car going 60 miles per hour, everything on the road seems to be going past you 60 miles per hour backwards. So the train is moving 30 meters per second forward. He sees the magician falling behind him at negative 30 meters per second. How does the passenger see the runner moving? The passenger sees the runner. That's a tough one. Well, you could use the magician to help you out with that one, right? So if the passenger sees the magician falling behind him at 30 meters per second, the runner falls behind him even more because the runner's running opposite the direction of the train. So I would say that's negative 40 meters per second. If the runner was going 100 meters per second backwards, then it would be negative 130 he would see him at. How does the passenger see the suitcase moving? Well, they're both just sitting still on the train. So that is 0 meters per second. And how does the passenger see the ball moving? That's a given in the problem, negative 20 meters per second. That's how fast he's able to throw the ball. All right, now we're going to do row 3. You do it on your own. Try it out, and then watch me do it. And if you get any answers different than me, you could come up and ask me why they're different. All right? Okay, so what does the runner see? How does the runner see the magician? Well, the runner is moving backwards at 10 meters per second on the platform. So he's getting further from the magician. So the magician seems to be moving to the right from the runner's perspective. If the magician's getting more forward relative to the runner rather than closer to the runner. So the magician seems to be moving in that positive direction right there. And basically the only speed that counts is the speed of the runner going backwards there. The magician would see the runner going at negative 10, but the runner sees the magician going at positive 10 meters per second. How does the runner see the runner? 0, not concerned. How does the runner see the suitcase moving? Well, the runner sees the train going 30 meters per second to the right, but then on top of that, he's going 10 meters per second in the other direction, in that negative direction. So the train seems to be going even faster to the right relative to the runner. So I would say the runner sees the suitcase going at a positive 40, add the 30 and the 10 meters per second. How does the runner see the ball moving? So this is probably the toughest one you're going to have to do. All right. The runner sees the ball. Well, let's see how the runner sees the train first. The runner sees the train moving 40 meters per second to the right. But on top of that, the ball is moving backwards at 20 meters per second. So just use stuff you've already done, basically, and to say that, oh, I'm going to take away 20 from that because the ball is getting closer to the runner. There you go. Now, we could do one really weird thing just to finish this off. Change the speed of the ball to 30 meters per second. All right? And I want to ask you now, how does the magician see the ball? Because the ball is on the train, it's thrown backwards at 30, and the train's moving forwards at 30. The magician sees those two do what? Cancel out. So how would the magician see the ball? Some may say floating, but I would say it almost looks like it's floating. It more just looks like it's dropped, because the 30 and the 30 would cancel out and the ball would just fall straight towards the ground. If you have two speeds like that, they cancel out. The speed would be 0. And it depends on the perspective, you know. It's not a hard and fast rule. You just have to recognize when that occurs.